Hi friends, welcome to this presentation. We are going to be modeling, analyze and design this simple workshop building. The straight trusses resting on the concrete columns. If I should select the first straight truss, right click and then click on the steel member design, you see all the members has been designed successfully. While there's a one in here at the slenderness check, right? So this is what we are going to be looking at. Click on OK. Also, I will navigate to the new project. I'll save this project. I'll give the project name. Add one to separate the name from the previous one. OK option. We'll be using BS at 110 import. At this point, we are going to start to create the grid lines. So we go to orthogonal axis generator. In this, we are going to be having 750, 7,500 millimeter times 3. The total length of the truss is 15 meter. All right. So in the axis label A, we are going to be having 5,000 spacing between the columns and into 5 places. Click on the OK. Alright, so this does not give us what we actually expected. You have to delete this first. Click on delete, go back to auto. Gonna ask the generator, click on these provisions. We have to have 7,500 as terrace 2. Alright, while these provisions will be 5. Click on OK. So this is what we actually expected. At this point, we'll proceed to place the reinforced concrete column. Click right there on the column. The section we'll be considering is 300 by 300 concrete sections. So we want to select all of these, a sheet over the intersections of the grid lines to place the columns just like this. Alright, click on the closed to close the column dialog. Navigate to the 3D and you will have this. Alright, at this point I want to navigate to the foundations. Editing, history editing. We'll be having the height of the column to be 3,500 millimeter, and then the foundations depth is going to be 900 millimeter. Alright, click on OK. Yes, options. After which we want to be creating the ground beams. So we navigate to the story 0. Save this project first. Alright, for the ground beam, select the beam member. Specify the beam sections. We'll be having 300 by 450 for the ground beam. Alright. Then we'll go to the 3D tab. Then at the level of the beam, we want the level to flush with the DPC level. So for us to do that effectively, at these provisions, we are going to type subtracting 900 from the sections of the foundation beam. Sections of the foundation beam is 450 depth, so you will having left with 450, and then you start to insert the beams. You can navigate to the plan view just like this, then click here, draw this across to insert this beam just like this. Now navigate to the 3D view, so you have the beam inserted successfully just like this. Okay, so the next thing will be placing slab at this DPC level. So close this dialog, and activate the slab. The slab thickness we'll be considering is 180. This is a workshop, right? Then the concrete cover will have it to be 25. We come to the loads. In these provisions, additional dead loads, partition and finishings will be having 2 for the imposed load for workshops. We use this 2.5. Right? Then the reference level. We calculate the reference level. We have the thickness of the slab to be 180. So you have to do a simple calculations. 180 minus the 900 millimeter DPC. So what do you have? If I should activate the calculator to check that out. We'll have 900, which is the depth of the foundations, minus 180 equals, we have 720. So 720 is the value we are going to input in these provisions. 720 millimeter. Place the slab, you can see right there. Then continue to place it in the rest of the provisions. Right? After which, close this dialog. So we proceed to place a beams so as to bind these columns together at the headroom level. So we activate story 1 and then click on the beam. This beam is going to be 300 by 350 depth sections, just like this. At the 3D level, we are going to be sending these beams downward at minus 300 so that it will not clash with the base plate. That will connect the steel trusses and the reinforced concrete columns. So after which we will navigate to the plan view, just like this, and click up there, do a sheet over all the intersections, release your hand to place the beam, just like this. Navigate to the 3D. So this is what you have, this is what is expected. Okay, close this beam dialog. Alright, so there will be a wall on this ground beam. So we are going to be applying a wall load on this external ground beam. So select the first one, right click, click on the edit beam wall load. So the walls we'll be using right there is going to be 4.7 kilonewton per square meter unit weight. For the height, we are going to be considering 3,300 millimeter, which is 3.3 meter. So 0.3 meter is the wall thickness. So if you want to create an opening, you use this edit openings, but we design for the worst condition, so there is no need for creating openings. Click on OK to inside the wall, just like this. Get the wall selected, right click and copy it. The beam wall load, select all the external by holding down the control key, all the external beams, just like this. Alright, right click and then select paste, copy it, beam wall load, yes options to have the beam wall load paste successfully. After which we want to be erecting the steel trusses. For the steel trusses, we click on this steel truss tab. To activate it, pick the first point of the truss and the last point of the truss, and then we need to choose this one, this type of truss we are going to be considering, and then we'll select this one. So having this selected successfully, we want to be having a right cantilever length to be 1000 millimeter. Then the left cantilever length to be 1000 millimeter as well. So we screw down. For the numbers of divisions, we'll be having 7. Along the span, screw down. Along the right span, we'll be having also 7. Okay. And so we screw down for the top and bottom cord. Top cord left extensions. We may not necessarily have anything there. Then in this provision where we have left heel height, we'll be reducing this to 700. And then this provision also to 700. You can see the changes here. Right? So after which, when we navigate to the members, for the top cord member, we are going to be using a square pipe 100 by 100 by 8 thickness. Alright, select that. Okay, for the top cord, the same thing applicable to the bottom cord. Alright, select that, click on OK. Then for the diagonal, we are going to be using the same sections, the same pipe but different section, this time around 700 by 700 by 5. Alright, then for the vertical, we also have the same pipe 70 by 70 by 5. Select that. Okay. After which, click on OK to insert the truss. Then we continue to place it along the columns, just like this. After which, right click to deselect the command. Then we will be placing the purlins. For the purlins, select purlins, select the first truss and the last one. Activate the purlins again. Select that and this one to have this. Alright. So for the left extension, so this is the profiles of the purlin. Okay. And then the section alignment is on the sections. Then for the right cantilever length, we will be having 1000, and as well the left cantilever length, 1000 there, also 1000. Okay, after which we'll be applying load. So click on loads and then add load. The G load will be having it to be 0.5, and then select the group 1, select all, apply it. Alright, for the feed 2, select all, apply it. For the field 1, select 1, apply. You just have to apply to all the field in all the groups. Right, just like this. So this is how you apply load on the purlins successfully. Alright, so that is done. Go to the queue, add load. For the value of Q, we'll be considering 1.5, and then we also need to apply it. Alright, so having applied that successfully, just have to click on the OK button to insert the purlins, just like this. So now we go to Analysis tab, Building Analysis. So in the Building Analysis provisions, come to Parameter, and then for the foundations design, we'll have 100 as the soil bearing pressure. Okay, click on OK options. Come to loadings, generate load combinations, click on OK. Load cases, apply that, click on OK. Alright, OK again. And then for the materials, we are going to be starting from the foundations. We'll be using C20 and 25. Click on OK. Then for the steel grades, we are to be considering type 2. Click on OK. For the rebar, for the foundations, we consider 16 and 12. Every other bars have to be deselected. Click on OK. Go to the default materials. For the default materials in the steel grades, Y60 apply to all. OK. Then for the concrete, we will look at 16, 20, and 25. Alright. I'll check that. Click on OK. Then for the beam, the same thing applicable to beam. We will look at 16, 20, and 25. Okay. For the slab, we will be considering 12. We will consider 16 only for the reinforced concrete slab. Then for the links, we will be looking at 12 and 10 for the links. Just like this, we don't have web bars in this case. For the steel strength, we are going to be using strength 275. After the design, the program will select the right strength for the steel members. Alright, click on OK. And then close this dialog. Save the project first. Okay, so after which we are almost set to do analysis, but we will do one more settings. Come to setting, click on the column design setting. In the column design setting dialog, navigate to steel bar and longitudinal bars. You see column bar size 16, minimum, maximum have to be selected. Just like this. Then come to links and ensure that the minimum is selected. Click on OK. And then save this project first. After which, go back to setting again, this time around beam, setting, story beams, click on that. In the story beam dialog, on that parameter, you can be able to select the maximum steel diameter for the beams to be 25. Then for the links, select 12. Alright, the reason for this is for your beam to be designed. If you don't select the maximum and the minimum reinforcement diameter, the beam may not be designed. Click on save. Save this project first. Each time you make changes, ensure you save the project. To make it effective, go back to settings again, beam design, then come down to foundation beam. We have a foundation beam right there. So in the foundation beam dialog, you make sure you check everything just like this. Okay, save it. Click on save. Also go back to save setting. This time around it's going to be foundations. Change this minimum steel bars to 12. Click on OK. Go back again. Check slabs. Sorry, we have foundations. Go to slab design. In the slab design, check the steel bar. Minimum is 12. Click on OK. Save the project once more. At this point, we are set to run analysis of this structure. Okay. So for the analysis, we will navigate to the analysis tab. Select building analysis. In this building analysis, go straight away to analysis. Check the building for any error. Start the check. You notice we are having 0 error. Close that and then ask the structure to design columns, design beams, and check the steel members. Click on start. Alright, so you see this morning, because of spare server is activated, so spare server matrix has failed. Click on OK. So this end the analysis prematurely. Click on OK. We need to deactivate spare server, so go straight away to model option settings and then use spare server for building analysis. Deactivate that. After which, go back to analysis again. uncheck steel member design check, uncheck all of these, and then go again and start design. Choose that. Analysis is ending prematurely. Okay, so when you're observing that, can try to check the steel member design, carry out analysis again, select that, start it again. So video analysis is in progress now. Click on continue, yes, options, continue. Also continue, video analysis completed successfully. Click on OK and close this dialog. Analysis is done on this structure. So for the design, the reason for most of those warning you're seeing is because the steel trusses is resting directly on the concrete column. So that is why you're seeing most of those warning. All right. So now we are going to be designing the structural members. So we start from the columns. So if you select the column right away, right click and then click on the column section design, you notice the column is now designed. So what you do, use column design bash mode, click right there, select, reselect all bars, design it. So after we click on close, you see the columns now is designed successfully. All right, these are the bars arrangement. Close this. This time around we're going to design the beams. So select the beam, right click, select that options, these options, we select all bars, calculate that, and the story one beam is successfully designed, you can see. So you close this again. Let's go for the foundation beam. So double click on the story 0, locate and navigate to the beams right there, which is the foundation beams, beam reinforced design active story, which is the story 0, bash mode, reselect all bars and calculate. So this is the design process. So the foundation beam has been designed successfully as well. We close this dialog as well. The next thing is the steel members. For the steel trusses, we need to design it so we can be able to carry out the connections. So select that, right click, and let's click on the steel member design. You can see there is no result here. Slenderness, utilizations, and statutes you get. You have to click on check all members. Do the progress sometimes. All members has been checked successfully, and members has been passed except the top chord. One of the top chord is having a slenderness ratio issue, which is not a problem, as well as the bottom chord slenderness ratio issue, which is not a problem. In as much as the utilization ratio has passed requirement, everything is good. Click on OK. So this one now is designed. Save the project first. After we will proceed to the next steel member, this one, steel truss, select that, right click, click on member design, check all has been designed, and then this one is failing. This particular utilization ratio is more than 1, so it's failing, and that is the bottom chord. That's the bottom chord. All right, so what you just need to do right there, you can change the sections right there. So use it, the thickness 10 right there, select OK, OK again. All right, it has reduced but it's still failing. Okay, go back to change sections again, and this time around you can switch to 120 by 120 by 5. Select that, click on OK. Still fair. You increase the thickness of that. Increase the thickness to 8. Click on OK. Okay, it's past design now. For the slenderness ratio, there is not an issue. Click on OK. Alright, so we proceed for the rest of the trusses to make sure all the trusses are being designed successfully. So for the Purlins, you choose the Purlins, you right click on steel member design, see everything about the Purlin has passed. Okay, for the calculation detail, open here, you can see the calculation details of that. Okay, click on OK. Alright, so having designed the whole of the structures, now we are going to be looking at the foundation design. So we navigate to Story 0, right click and go to the plan view of that. Save this project first. After we will get all the columns selected at this level, so you pick it one by one, go down the control key to ensure all the columns are selected, just like this. So after which, just right click and then you select insert part base. So uncheck here, so it's not going to have a typical part base. All right, click on OK and give it the program sometimes to insert the part base depending on the loadings other particular columns. So the part base creation is actually in progress. All right, so this is successful. If you zoom closely, you know this is 1 meter by 1 meter and the thickness is 400 millimeter, which is the 14 thickness. All right, so you can now navigate, save the project first. You navigate to the 3D. So you can see this is what the design looks like this. Okay, so we have been able to model, analyze and design this simple workshop successfully, including steel trusses as well as the Purlins. In the next lesson, we will be looking at the connection design, all right, using the Protastructure. So stay tuned, subscribe, and then see you in the next lesson. This is car level 100. Once again, you are welcome. Bye for now.